In this unit, we will introduce the chain rule to help us differentiate nested functions. For example, the exponential of x squared. We will apply this rule to polynomial functions, logarithmic functions, and exponential functions. Recall that in a previous unit, we had the following rules for differentiating standard functions. When differentiating x of n, we times by the power and drop the power by 1. When differentiating e of x, we just got e of x. When differentiating the natural log of x, we got 1 over x. And finally, when differentiating a of x, we got a of x log a. We will now look at how we can generalize these rules to deal with nested functions. So instead of differentiating x to the n, we differentiate some function of x, say 2x plus 1, to the n. To do this, we will use what's called the chain rule. The chain rule, or function of a function, says that calculating dy by dx is equivalent to calculating dy by du times du by dx. And this is true because the du's will effectively cancel out. This allows us to take the composite part of the function, say the 2x plus 1 that we discussed earlier, and call it u. We can then use this rule to differentiate that function with respect to x. Let's have a go at this example. We wish to differentiate x squared minus 1 to the 5. Let's call this function y. Setting u equal to x squared minus 1, we have that y is equal to u to the 5. So dy by du is 5u to the 4. We've times the power and dropped the power by 1. And du by dx is equal to 2x. We can now use our function of a function rule. Dy by dx is equal to dy by du times du by dx. This gives us that dy by dx is equal to 5u to the 4 times 2x. But u is equal to x squared minus 1, and so we have dy by dx is equal to 5x squared minus 1 to the 4 times by 2x. We can see here that we have times by the power and dropped the power by 1, and then we have now multiplied by the differential of the x squared minus 1. Let's have a go at differentiating 1 over 3x squared minus 5x plus 2 with respect to x. Again, we'll call this function y. Recall that with reciprocals, we write them as negative powers. So we have y is equal to 3x squared minus 5x plus 2 to the minus 1. Setting u equal to the nested function of 3x squared minus 5x plus 2, we have that y is equal to u to the minus 1. So dy by du is equal to minus u to the minus 2, timesing by the power and dropping the power by 1. Du by dx is equal to 6x minus 5. We can now use the chain rule to calculate dy by dx, which is equal to dy by du times by du by dx. Dy by du is minus u to the minus 2, and du by dx is 6x minus 5. But wait, u is equal to 3x squared minus 5x plus 2, and so we have minus 3x squared minus 5x plus 2 to the minus 2 times by 6x minus 5. And I better put brackets in there so we don't get confused. We can see that once again we have times by the power and drop the power by 1, and then we have times by the derivative of the nested function. Here's a further example. Setting u equal to the nested function of 2 minus 6x, we have that y is equal to the exponential of u. Dy by du is equal to e of u, and du by dx is equal to minus 6. Using the chain rule, we can calculate dy by dx. This is dy by du times by du by dx. Dy by du is e of u, and du by dx is minus 6. But remember that u is equal to 2 minus 6x. So we have e to the 2 minus 6x times by minus 6. We can see, just like differentiating e of x, we still have the exponential of the original function. However, we now have a bonus part where we multiply by the derivative of that nested function. Let's have a look at differentiating log of 5x plus 2. Setting u equal to 5x plus 2, we now have f of u is equal to log of u. Differentiating f of u with respect to u gives us 1 over u. Differentiating u with respect to x gives us 5. So using the chain rule, d by dx of f of x will equal d by du of f of u times by du by dx. This gives us 1 over u times by 5. But u is equal to 5x plus 2, and so we get 1 over 5x plus 2 times by 5. Just like when we differentiate log of x, we do 1 over the function, and then we times by the derivative of that nested function. Finally, let's look at differentiating y is equal to 2 to the x cubed. Setting u equal to the nested function of x cubed, we have that y is equal to 2 to the u. So dy by du, using our standard result, will be 2 to the u log 2. And du by dx is equal to 3x squared. Using the chain rule, we have that dy by dx is equal to dy by du times by du by dx. dy by du is 2 to the u log 2, and du by dx is 3x squared. But u is equal to x cubed, and so we have 2 to the x cubed log 2 times 3x squared. You can see we have repeated a similar method to differentiating 2 to the x. We get 2 to the x cubed log 2, and then we times by the derivative of that nested function. We have just seen in our examples the following general rules. When differentiating x to the n, we times by the power and drop the power by 1. When differentiating a function of x to the n, we do the same thing, times the power, drop the power by 1, and then we times by the derivative of that nested function. When we differentiate e of x, we got e of x. Now when we differentiate e of f of x, we get e of f of x, and then we times by the derivative of that nested function. Similarly, when we differentiate log of x, we got 1 over x, and when we differentiate log of a function of x, we do 1 over the function, and then we times by the derivative of that nested function, and so on. It's important that you understand these shortcuts, as exam questions will require you to use the chain rule innately. So using the shortcut, to differentiate this, we would times by the power and drop the power by 1, and then we times by the derivative of that nested function. The derivative of this will be 0.6 e to the t. To differentiate y equals the exponential of 50t plus 10t squared, we use the fact that when we differentiate an exponential, we just get the exponential to the same power. But now using the chain rule, we'll times by the derivative of that nested function, which will be 50 plus 20t. Next, we're asked to differentiate minus 20 log of 1 minus t over 5. Well, we know that when we differentiate a log, we just get 1 over the function. So we have minus 20 times 1 over 1 minus t over 5. But using the chain rule, we times by the derivative of that nested function, i.e. the derivative of 1 minus t over 5, which will be minus 1 over 5. Finally, let's look at a slightly more complicated example where we'll have to use a double chain rule. We wish to differentiate the exponential of e of x squared plus 1. Well, we know that when differentiating an exponential, we get the exponential with the same power. However, using the chain rule tells us we need to times by the derivative of that nested function. Well, the derivative of 1 is 0, so we just need the derivative of e of x squared. But to do that, we'll need to use the chain rule again. Differentiating an exponential gives us an exponential with the same power, and then using the chain rule, we'll need to times by the derivative of that power, 2x.